My name is Neha Takawale. I have a background in Linux system administrations and cloud technologies. Currently, I am doing an internship at CyberSapiens where I am learning and exploring cloud security concepts. Today, I will be presenting the topic of securing AWS using identity and access management and zero trust principles. In this presentation, I will explain how IAM helps manage identities and access permissions and how the zero trust approach improves overall cloud security. So let's begin the presentation. So first let's see introduction to IAM. So what is IAM? IAM is the identity and access management. It is a core AWS service that helps manage access to AWS resources securely. It allows administrators to control who can access resources, what actions they can perform, and under what conditions. IAM plays a critical role in protecting sensitive data and preventing unauthorized access. Moving on to the next slide. Why IAM is important in the cloud. So first we'll see the robust security foundation. So how it's robust? Because it provides a centralized access control for cloud resources. It supports multi-factor authentication for stronger security. Another is essential for compliance. It helps organizations meet security standards such as ISO 27001, SOC 2 and PCI DSS. Also it maintains access logs and monitoring. Another one is the effective risk mitigation. How it reduces the risk? It reduces the unauthorized access and insider threats. Also it improves overall cloud security postures. Another one is the enhanced operational efficiency. It reduces manual security configurations. Also simplifies management of large cloud environments. Moving to the next slide. It's cloud IAM components. So let's see users. Users represents a persons or application that interact with the AWS services. Each IAM user has a unique identity and it is associated with security credentials such as a password, access key or MFA devices. Another component is groups. So IAM groups are the collections of IAM users. Groups make permission management easier by allowing administrators to assign policies to a group instead of individual users. If we can take an example, users belonging to the development team can be placed in the developers groups and finance employees can be placed in the finance group, like that. Third one is roles. So what is the role? Roles are the identities that provides temporary permissions to trusted entities. Unlike users, roles do not have a long-term credentials such as a password or access key. Fourth one is IAM policies. Policies are JSON documents that define the permissions. They specify which actions are allowed or denied on specific AWS resources. Moving on to the next slide is the IAM architecture in cloud environment. So basically IAM architecture is designed with the four main important components: identification, authentication, authorization, accounting. Let's start with the identification check. It means organizing who the user is, or it means identification means recognize who the user is. Every user or system has a unique identity such as a username, user ID or application identity. If it is passed, move on to the authentication. Authentication verifies the identity of the user. The system check credentials such as a password, security tokens or MFA, multi-factor authentication, to confirm that the user is genuine or not. Then go towards the authorization. Authorization determines what the user is allowed to do. Based on the policies and roles, the system decides whether the user can access specific resources or perform certain actions. And then finally, accounting. So in accounting, keeps a record of all user activities such as login attempts, resource access, change made in the system, which helps in monitoring, auditing and security analysis. Moving on to the next, access control models. There are two access control, role based access control, and another one is attribute based access control. So in the role based access control, it is a security model which is used to manage access to the system and resources. Instead of assigning permission to each individual users, permissions are assigned to the roles based on their job profiles. For example, in an organization, we may have a role such as administrator, developer. Each role has a predefined permission. When a user is assigned to a role, they automatically receive the permission associated with that role. Then another one is attribute based access control. So it is a security model where access is granted based on the attributes instead of only roles. Attribute can include information such as the user's department, job role, locations or the type of resources they are trying to access. For example, user from the finance department may be allowed to access financial data only during working hours. Moving to the next topic, it's securing AWS with IAM and Zero Trust. Let's first see least privilege enforcement. It means users are given only the permissions they need to perform their jobs. For example, a developer may be allowed to launch EC2 instance but may not have the permission to delete important production resources. Let's see, for the second one is the zero trust architecture. It follows a simple principle like never trust, always verify. Every user and device must prove their identity before accessing the resources. Third one is reduce attack surface. We can reduce the attack surfaces by limiting unnecessary access. When users have restricted permissions, attackers cannot easily access critical system even if an account is compromised. Fourth one is real-time detection. We can do this real-time detection through the CloudTrail logs. It monitors user activities and quickly detects suspicious behavior such as unusual login attempts or unauthorized actions. Last one is a measurable results. It allows organization to track improvement in security. By implementing IAM and Zero Trust, companies can reduce security incidents, improve compliance and maintain a stronger cloud security posture. Moving on to the next, AWS based practices. So first one is the enable MFA, nothing but the multi-factor authentications for important account. This adds an extra layer of the security by verification steps during login. Another best practices is IAM, identity and access management, to control who can access AWS resources. Then least privilege access. Its users should be given only the permission they need, which is called the principle of the least privilege, and monitor and audit. Here we can monitor and logs the activities to detect suspicious behaviors. Let's move on to the next. IAM challenges, complexity at scale. In this, managing identities and permissions across multiple cloud account and service becomes increasingly complex. Then credential management. Users and applications require credential like a password or access key, and if these are not managed properly, they can lead to security risk. Third one is shadow IT and unauthorized access. It is also a concern. Sometimes employees use cloud services without approval from the IT team, which can create security gaps and increase the risk of data posture. Fourth one is compliance and audit requirements are another challenge, as organization must follow security regulations and maintain proper access logs to prove and their systems are secure. So fifth one is identity sprawl. It occurs when too many identities are created across different systems and services, making it difficult to track and control who has access to what resources. Let's on to the conclusion. So I am as a gatekeeper, then it's build a strong fundamentals, evolve with automation for the continuous monitoring and zero trust architectures, also continuous improvement with regular policy refinement and ongoing monitoring are essential for its continued improvement. Let's move on to the demo part. Here we can search for the IAM service. Click on that. As we seen earlier, there are key components of IAM: users, roles, policies, and user groups. So here we can create a different users from this create users. I have already 3 users in my account. Next we can see for the roles. So here we can create a role from this. Here they have given different entity type. If you want to create the role basis on the service or basis on account, web identity, they have given the several options. If you want to create this roles with AWS service, you can create with. Now I want to create a role for EC2. I will select the EC2. Next, then which permission I need to add to the assign to that role, that EC2 read. So I will assign this permission and then next it will add. So you can give here role name, description, and this is the JSON format for the policies. I am not creating it because I have already created the roles. So just showing to you. Next is the policies. So what is in the policies? There are the different policies are given here. Already AWS has built policy. So EC2 read, you can give it from these policies also, read only access, or if you want to create your customized policies, you can create from that. Create a policy for let's see, I want to select a service. Okay, here you can select a service whatever you want, EC2, S3, Lambda, like this. If I am select S3, okay, this is for the policies. Here you can select, you can see here you can script in JSON format also, and you can create the policies here also. You can edit the policies as you want. So next you can do, I am not creating it. So go to the IAM policies. That's the demo, and here the user groups you can see. I have created one group for the admin, and this admin I have created these 2 users, Alex and intern. Okay, that's it for the demo. Yes, moving to the PPT. That's it. Thank you.